Hi guys, my name is Arvindh. Welcome to 6th grade math with all STEM. Today we will be discussing statistics and probability. This video covers the basics of statistical questions, creating and using data sets, describing variability, and collecting data from real-life examples. As always, our videos contain between 8 to 15 review questions. Each one is timestamped in the description box. If you get a question right, feel free to skip to the next timestamp. Otherwise, please watch the full explanation for each question. If you want to review certain topics after the video, we have a links to further reference page in our description box down below. On this page, we have a link for each question so you can dive deeper into the challenging ones. These links are great for extra practice. Alright, let's get started with the first question. Hey guys, so let's go over, before we start, what we're gonna do today. So we're gonna recognize a statistical equation as one that anticipates variability in the data related to the question and accounts for it in the answers. Next, we're gonna understand that a set of data collected to answer a statistical question has a distribution of data points. Then we'll understand that both a measure of center and a description of variability. And next, we'll display numerical data in plots on a number line. And lastly, we'll summarize numerical data sets in relation to their constant. So let's jump right into our first problem. So first, this is really simple. Choose all that represent a statistical question. And there are going to be multiple on here. So just simply write, 1, 3, 6, 7, or that was just an example. Just write them out like that, and we'll check in a couple of seconds. Ready? 3, 2, 1. So your answer should be 1, 2, 5, 7, and 8. Now let's go through why I chose these. So a statistical question is a question that collects data that varies. Okay? So 1 is, what teaching styles are used by teachers for managing the behavior of students in this middle school? This is definitely a statistical question because there is the same type of data except it varies. Okay. 2, how many hours per week on average do students in our school exercise outside of school activities? That is also 1 because the numbers can vary. 3, who has the longest name in our class? This is not 1 because that is just going to give you one answer. Like, let's just say John. If that was the longest name, that is not any data. That is just an answer, but it's not data. Data shows variation, which you can see in our picture over here. 4, what was the temperature this morning at 6 a.m. at Raleigh-Durham International Airport? That is definitely not 1 because there's no data. That is just one temperature measurement. There is no variation. You could say, what was the average temperature at 6 a.m. at Raleigh-Durham International Airport over the course of 3 months? That counts. 5, does getting fewer than 8 hours of sleep the night before a standardized exam make 6th graders more likely to do poorly on their EOGs at Middletown Middle School? Yes, that definitely counts. Because if we have 2 students who got 2 hours of sleep get a 3, 3 students who got 4 hours of sleep get a 4, and 5 students who got 9 plus hours of sleep get a 5, that is definitely some statistical distribution. Okay, number 6. How many aunts and uncles do you have? Definitely not. That is simply a 1-number answer. Number 7, what proportion of students at your school eat cold pizza? That is definitely 1 because you can get different answers from that, and there's actually a set of data there. Lastly, what is the relationship between playing AAU basketball in elementary school and making the varsity basketball team in high school? That is also 1. 8 students played AAU. All 8 of them made varsity basketball. Did you play AAU? Yes. Did you make varsity basketball? Yes. Did you not play AAU? Did you play AAU? No. Did you make varsity basketball? No. Did you play AAU? Yes. Did you not play? Did you make varsity? No. See, you see these variations here? That is what gives us data. Okay, let's do our second problem. So Miss Flower's sixth grade science class Miss Flower's sixth grade science class was studying insects and wanted to know the average length of a red work ant. As a class, they measured ants. They measured the length of red work ants and displayed the data in the following histogram. So there are two parts to this question. One, describe the distribution, and two, what information does this graph give us about the group of red work ants in the sample? Okay? And the distribution is simply just the skew or the placement of the data points on the graph. So pause the video, solve the question, and in a few seconds we'll check. 3, 2, 1. So for part A, tends to be shorter at 5 and longer at 8. And B, most of the ants are either really short or really long, and we can determine that from the frequency and the body length axes. So let's take a look at this graph. So the body length of around 5 millimeters is a lot, and around 8 is a lot. So there is a lot of data at these 2 points. So we know that they can be really short or really long. Okay? And most either tends to be really short or really long, like I just said. And we can determine that by the frequency, aka the amount of data points here, and the body length axes. The y-axis on this graph is going to be our body length axis. Let's do our third problem. The diagram to the right shows the test scores for a sixth grade mathematics class. Without performing any calculations, use the graph below to show how you know that the mean and median test scores are both 92. And it's actually the graph to the right, not below. So solve the question, and in a few seconds, we'll check our answers. 3, 2, 1. So the best explanation is because 92 is right in the middle. So, let's go into this. So the best explanation is that the median mean take the middle number most of the time. And 92 is right in the middle of the number line. So this can be the best guess. Now, we are not supposed to use any mathematical calculations. Also, notice how this graph follows a similar behavior. Up, 1, 2, 3, down, stay here, 1, 2, 3, up, down, 1, 2, 3. Notice how it kind of looks symmetrical. This means that the graph follows the same behavior, so 92 would mathematically be a good guess. So when you perform calculations, obviously you're probably going to get another number, or you may not, who knows. But when you're not making any calculations, 92 is the best guess in this situation. Number 4, identify the distributions for the 5 different graphs. Graphs A, B, C, D, and E. Now, if you haven't learned exactly the names of distributions, well, first of all, that's why you're watching this video. You'll find out soon. And second, if you don't know, just take your best guess. Think about modes, modal distribution, which is all these types of distribution. So think about that and how you can use the term modal and use some prefixes that you know, like uni, bilateral, all of that, all of those terms to kind of describe these. But note that unilateral, bilateral, all of those may not be exactly the terms to describe these. Anyways, pause now and we'll check in a few seconds. 3, 2, 1. So A is skewed left, B is symmetrical or unimodal, C is skewed to the right, D is bimodal or multimodal, and E is uniform or monomodal. So let's go through all of these. Skewed to the left. Let's make an example graph. So clearly all the data in this graph is on the left side, so it's skewed to the left. Symmetrical. So yeah, skewed. Oh, I'm sorry, I gave the wrong definition. Skewed means that it's pushed away. So it's not going to be here on the left. I'm sorry, I mixed that up. Now, B is symmetrical or unimodal. Remember how we talked about symmetry in the previous problem? C is skewed to the right. Okay, there's less data on the right. D is bimodal or multimodal. So there's also symmetry here, but there's different distributions. It goes high, then low, then high, then low. Okay? Let's erase this. Okay? And lastly, E is uniform or monomodal. All the data is the exact same, so it's going to be considered as uniform. Let's do our last question, question number 5. So during the winter, schools are often closed due to severe weather. Sometimes schools have to make up for the missed days. A local school district wanted to look at historical data on the number of days missed due to inclement weather. The following graph shows the frequency distribution of the number of days missed due to storms per the year. So there's 3 different parts for this. First, analyze the graph. Does anything stand out? B, what are the tendencies? C, how many days were analyzed? So take a look at this graph. Feel free to pause and take a look at it longer, or just pause to solve it. And in a few seconds, we'll check our answer. Ready? 3, 2, 1. So there's an outlier at day 14, and the max is between 1 and 3. That's what usually does stand out in graphs like looking like this. B, there's a tendency at the left side because most of the data is pointed up there. And C, it's measured over 14 days. So let's dive into each of these. So there's an outlier at day 14. There's only one data point here and there's nothing in between. There's a max between 1 and 3. This is where our max is in that area. So B, there's a tendency at the left. Yes, all the data is located on this side of the graph. If I draw a line straight through the middle, all of it is here. None of it is on here. Well, very little data is on that side. And C, it's skewed over 14 days because our smallest data point is 0 and our largest data point is 14. So we have data spanning from a range between 0 and 14 days. I hope that this was a great review of these topics. Like I said at the beginning, make sure to check out our links for further reference page to get more practice on these topics. Do these questions help you out? Do you have any more questions? Let us know in the comments down below. As always, thank you so much for watching. If this video was helpful, please make sure to like, share, and subscribe. I hope to see you in the next video. Bye.